Alrighty, I hope you did try to rotate these. And first one we're gonna do is y equals around the x-axis first. So we know our functions and we know what we're rotating around. So the x-axis here. So first we want to draw it out once again. I want to make a bigger picture. So let's draw that out. We're going to get square root of x just like that. And we're going to get y equals x like that. So we know our bottom function is y equals x and our upper function is y equals square root of x. That's important because when we're rotating around this axis, around the x-axis, that's where we're going to start. So let me just shade in this area first. This is our region that we're going to rotate around the x-axis. So let me just put that x and y. So if we start from our axis, the x-axis, or wherever we're rotating from, we start. And wherever we hit the curve first, that's our inner radius. You call that the inner radius. That's our inner radius. So if you can imagine in your head, when we're rotating this, that's going to be on the inside. And when we start from where we're rotating again and go up, wherever we pass the first curve and then we still are in the region but we hit the next curve, that's called our outer radius. So outer radius. And I'm just going to abbreviate these from now on. I'm going to call this IR and I'm going to call that OR for outer radius. So hopefully you do follow along with me when we do all these questions. So I'm going to erase the graph here. So since we already know the outer and inner radiuses, and so our equation once again is just, first we have to set them equal to one another. So we'll do square root of x equals x to get our limits of integration to see wherever they intersect each other. So we're going to get x equal to 0 and x equal to 1. I'll let you do those calculations on your own. That's when they're equal to one another, and that's why we have our limits that way. So we're going to have our region, which is bounded by pi from 0 to 1, and we're going to have square root of x first. So square root of x squared minus x squared dx, and that's the area or the region bounded by all of that, and that's where we're going to rotate. So if you guys want to solve that out, integrate that, just square root of x, square x, and you just solve from there, and you're going to get 1 over 6 pi, and that's your answer, and that's just simple integration from there. So the other one I asked you to do, the other two, we can do that one right now. It's y equals -3, rotating around that line now. So we rotate around y equals -3, we're going to have a slightly different picture. And you can't always assume that this one's always on top and that one's always on the bottom. So it's going to get a little tricky here. So we're going to draw the picture. And this is y equals -3. Y equals -3. We have our curve here, right there. Extend that. That's y equals square root of x, and that's y equals x. And we'll shade in the area, and look here. So first we'll do our outer radius, since it's a little easier, since they're both easy, but you just have to, this is all imagination. Like, you gotta imagine in your head. So we start from where we're rotating from and go directly up. We're going to go up, hit the x-axis. Remember, we did the x-axis first, and the outer radius there was square root of x. But we're going 3 units up here, and then we're going the same amount from last time, square root of x. That's our outer radius. So right here, because that's the curve. So we're going square root of x plus 3. We're going plus 3 since we're going from y equals -3 to the x-axis, and then we're going the same square root x. And then we do the same thing for the inner radius. We're going to go 3 units up, and then just go to y equals x. So right here. So that's our outer radius, and that's our inner radius. I abbreviated those, inner radius, outer radius. And this is going to be x plus 3. So now we have our outer and inner radiuses. And now you just set up the integral. The limits of integration will not change since you still intersect at x equals 1 and x equals 0. So that's not going to change. So a and b will not change. Your only things will change are the inner and outer radiuses since you change where you're rotating from. So I'll erase the graph here. And I'll show you what the integral should look like. So it should be pi integral from 0 to 1 of square root of x plus 3 squared plus on a minus, since we're minusing the outer radius square minus the inner radius square, x plus 3 squared dx. And that's the volume you're going to get, and that's y equals negative 3. And the last one I asked you to do was y equals 8. So this one's going to be a little tricky. If you are clever, you will get this one, but even if you're not, I think you can. So what we're going to do here, always draw the picture. Don't forget to draw the picture. And we'll have square root of x and x. So y equals square root of x, y equals x. And we'll have a curve here. Let me just extend this. This is going to get a little tricky here. Let me just erase all of this on top. We don't need this anymore. And extend the curve. And we have y equals 8. Right here, y equals 8. Shade in the area we're rotating. And right here is from 0 to 1. And we're rotating around this line. So y equals 8. And we'll start from where we're rotating from and go directly down wherever we hit the curve first. So that's our inner radius. So how much did we travel? We traveled 8, and we hit the square root of x. So this curve here. So we traveled almost, so the whole thing would be 8. But this much is square root of x. So we actually traveled 8 minus square root of x. That's our inner radius. And then we start from where we are rotating, go directly past the first curve, the inner, and then we hit the outer. We actually traveled the same thing. We traveled 8 minus x. This line here is x, this much is x. The whole thing is 8, so if you imagine, this is 8 minus x. So that's our outer radius. Again, our limits of integration will not change. So if I can fit it on the bottom here, hopefully I'll just write out the integral pi 0 to 1 of 8 minus x squared minus 8 minus square root of x squared dx should be your integral that you need to evaluate. So that is the end of this washer or disk integration with horizontal. There's also vertical and shell integration. But I hope you did enjoy, you learned some stuff. And if you have any questions, leave it down in the comments. This can get a little confusing when you're trying to rotate. And just know, if you're in the same quadrant, you're going to have to minus, since you don't have to travel that much distance. But when you're in a different quadrant, you got to travel more distance. But that's the end, and nitty gritty out.